All right, so today we're going to be talking about end behavior. This is basically just a little bit more, it's basically something we already figured out when we talked about domain and range. But it's just another basic piece of the domain. Um, if we, or I mean, not the domain, the range, when we talk about it. Okay, so let's dive into this. So first of all, you'll notice on these problems, um, they ask for several different things. They ask for the domain, range, end behavior, x and y intercept, and whether or not it's increasing or decreasing. Okay, so let's zoom in here a little bit so we can maybe see things a little bit better. Okay, so all right. So looking at this first equation, let's figure out the domain and range. So again, there should be arrows on the end of these lines here. These can mean they're going up to the left forever or down to the right forever. So the domain, as with pretty much any diagonal line, is going to be negative infinity and infinity. Okay. Range is also going to be the same, negative infinity to infinity. They go on forever, both left and right and up and down. Okay. Now, when we talk about end behavior, you'll notice it says as x is approaching negative infinity, it wants me to figure out what my y value is. So generally, this is going to be something involved in your ranges. It'll basically want you to figure out when your x value is going to negative infinity, or when your x is going to the left, what value is your y value approaching? So you notice as we go to the left, our y values are getting more and more positive, right? So if we kept going to the left, the y value would keep going up, which means as x goes to negative infinity, y would be going to positive infinity. It's going up forever when we go that direction. And vice versa, as x is going to positive infinity, or when it's going to the right, um, our y value is going down, right? It's going downwards. Okay. So if we go forever to the right, that means y is going forever down. So as x approaches positive infinity, y is going to be approaching negative infinity. Okay. So again, it's just variations of the range, but it's basically wanting to figure out what your y is doing at each end of the spectrum, basically. And then the x and y intercepts, they're kind of self-explanatory, right? X-intercept would be the point where your line crosses the x-axis. Your y-intercept, which you all should be familiar with at this point, is the point in which the y crosses, or your x crosses, your line crosses the y-axis. If I can speak English. Okay, so the x-intercept looks like it's crossing right there at -1 on the x-axis. Now, here's the key part: the x-intercept that it's asking for is the point. So the x-coordinate would be -1, but it also wants the y-coordinate. When you're on the x-axis, what is your y-coordinate? It would be 0. Okay, so the answer would be -1, 0. Ordered pair for that point. And it's going to want the same thing for the line. So when the line crosses the y-axis, so it's crossing right here at -3, your x value is going to be 0. So it's going to be 0, -3. And that would be your y-intercept. Then the last part is it increasing or decreasing. So when we read a graph, we always read what we read from left to right. Okay? So if we look at a line as we go from left to right, what's it doing? Oh, look, it's going down. Another word for down would be decrease, right? So this one is an example of something that is decreasing. Not too tough, right? Let's look at another example here. Let's look at something a little trickier. Let's look at the horizontal line. So the horizontal line right here, you can't see, I'll darken it a little bit. There's a horizontal line right there. So the domain, again, it goes forever to the left, forever to the right, is going to be negative infinity and infinity. Okay, but the range, since it's horizontal, it's never going up or down. It's always going to stay right here at this number, which is 5. So the range is just going to be 5. Okay, not too tough, right? And then as x goes to negative infinity, so as we go to the left, what's y value doing? Oh, look, it's never leaving 5. So as x goes to negative infinity, y is always going to be there at 5. Same thing as when we go to the positive infinity. Hey, look, y is always it's still there at 5. It doesn't move. Okay? X-intercept, it never moves from 5. It's never going to cross the x-intercept. So there, or the x-axis, so there is no x-intercept. So I'm just going to put none. Okay, but the y-intercept looks like it crosses right there at 5. So it'd be 0, 5. Okay? Is this increasing or decreasing? Well, it's not going up or down, is it? If you go from left to right, it's staying even. So this worksheet doesn't say it, but on the test and test view and stuff, there will be another option that is neither, which is what this is. Okay? It's neither increasing or decreasing. It is a horizontal line. Okay? So that's that one. Let's look at the next one here. So on this one, again, we have arrows at the end here. Looks like it's going forever to the left, so negative infinity. And it's going forever up to the right, so that would be positive infinity, so the domain is negative infinity. Range, though, this type of line is a little curved line, is what we call an exponential equation line, right? And with exponential equations, we will have what we call horizontal asymptote. Okay, if you remember, as we go to the left, these y values are becoming fractions that are getting closer and closer to whatever number this is on the y-axis, 1. Getting closer and closer to 1, but it's never actually going to pass it. Even though we go forever to infinity, it's going to get infinitely close to 1 without ever actually getting it. So the smallest y value that it's going to have here is going to be 1. It's never going to actually pass 1. It's just going to get infinitely close. And because it's not quite equal to 1, we don't use a bracket. We use a parenthesis to show that it's infinitely close to 1, but not actually including 1. Okay, and then the greatest y value looks like it goes up forever, so that would be positive. Okay, and then as x is approaching infinity, as we go to the left, what y value is approaching? Well, as we go to the left, it's getting closer and closer and closer to 1. So that would be the end behavior. As x goes to negative infinity, y is approaching 1. And then as we go to the positive infinity, it looks like y is going up. So it's going to go up forever, which is positive infinity. And then the x-intercept, hey, look, it's never going to cross the x-axis. If it never crosses 1, it's never going to get to the x-axis. So there is none. There is no x-intercept. Okay, but y-intercept looks like it crosses right here at 2. So it would be 0, 2. And again, we read from left to right. So as we go from left to right, our graph is going up, which means it is increasing. So our answer would be increasing on that one.